Okay, here's to finish off your note guide for conversions and the metric scale. This little example problem's not in your note guide, but it does show you how to do conversions. So if you follow along here, it will help you out for dimensional analysis. So you're trying to decide which laundry detergent to buy at the store. Detergent A comes in a 1.45 gallon bottle. Detergent B comes in a 6.5 liter bottle. Both bottles are the same price, which has more detergent for that price. So here's what we want to do. Essentially, we want to figure out how do gallons and liters relate to each other. And if you look at your little note guide, there's a set of conversions on there in a little table or equivalencies that allows us to go from gallons to quarts and then quarts to liters, but we don't have any conversion between gallons and liters directly. So this is kind of a setup for these problems that allows us to set up the units and which unit we're going to convert into and out of to get our answer. So in this case, I'm going to start with my gallons and go to my liters. If I want to do that, I want to know how do gallons relate to quarts and how do quarts relate to liters. These are called equivalency statements, and this would be looked up on a conversions chart. And I know that 4 quarts equals 1 gallon, that's on your little chart, and 1 quart equals 0.9464 liters. These equivalency statements can be turned into conversion factors, and here's how. We want a little ratio here. If you look at this guy, the 4 quarts equals 1 gallon, let's just say I divide both sides by 1 gallon. So it's going to be 4 quarts over 1 gallon equals 1 gallon over 1 gallon. And if you think about this, what is 1 gallon divided by 1 gallon? Well, everything cancels out there and it reduces to 1. And so I can write that 4 quarts over 1 gallon just equals 1. That means this ratio here is the same as multiplying by 1. I know it's not quantitatively, so if you look at your numerical values, 4 over 1 is 4. But when we're talking about our units here, it's essentially talking about multiplying by 1. It doesn't change my measurement. It's still the same amount of volume. It's still 1.45 gallons. We're just now in quarts. And so I can use this little ratio here. This is a conversion factor to do a conversion out of gallons into quarts. And that's what I plug in right here. And I want to show you that. Let me just let's go down to the bottom here. Well, you can follow my work here. 1.45 gallons times 4 quarts over 1 gallon. That's my little ratio here. We set this up so that the gallons end up canceling. Gallons are on top here. 4.15 or 1.45 over 1 is like what we start with our number here. And the gallons is our units on top. And a gallon over gallon, those cancel. So if I multiply this out, remember from your math class how you multiply fractions. We take what's on top and multiply straight across, and we take what's on bottom and multiply straight across. And if you multiply straight across the top, you get 1.45 times 4 for the numbers, and you get a gallon times a quart for the units. If you multiply straight across the bottom, you get 1 times 1, which is 1, and you get no units that we started with times a gallon, and we get a gallon. The gallons end up canceling here, and we're left with quarts. So essentially, when we multiplied by this conversion factor with gallons on bottom, we took our gallons, canceled them out, and we turned our unit into quarts. 5.8 quarts is the same as 1.45 gallons. How do I know how to do that? Always start with the number that you want to convert. This is a number from the problem that I wanted to convert. And then multiply by conversion factor so that your units and your number cancel. So I'm going to take my 5.8 quarts now. Same thing, start with your quarts. And now I'm going to take this ratio here, or this equivalency statement, and write it as a conversion factor. I want to get out of quarts, so the 1 quart is going to go on bottom, and the 0.9464 liters will go on top. If you multiply straight across again here, this is like 5.8 over 1. 1 times 1 is 1. I get 5.8 times 0.9464. If you multiply it out, you get 5.489. Quarts cancel, and I'm left with only liters. And if I keep track of sig figs, significant figures should be rounded according to the least number of sig figs in my problem. So if I go backwards through my problem, this is the number I started with. Don't use these. These ratios are exact. Only use the number I started with, 1, 2, 3 significant figures. I get 1, 2, 3 round to the 8 spot, so it becomes 5.49 liters. And 5.49 liters, it looks like that is less, so detergent B is a better value. How do we do this with the metric scale? Use this chart that was given to you, to get our equivalency statement. So here's how it works with base units on the metric scale. The metric scale has base units. Base units are what we use to measure different measurements like length, volume, things like that. So length in the metric, you have a little table with this on there. Length would be in meters. And we'll just look at length. Volume would be in liters. But the base unit for length would be the meter. And the meter has the abbreviation m, lowercase m. And these symbols right here, the prefixes, get attached to the m to mean something different. So the base unit, think of a meter stick for this length here. If you take the base unit, a meter, times 10 to the first power, that's times 10. So think of 10 meter sticks stuck together. You get a decameter, and that would be abbreviated DAM, a decameter. So my equivalency would be this. I can write this off to the side here. 10 meters, that's my base unit of the meter times 10 to the first power, equals 1 decameter, which would be a DAM. If I keep going up, base unit times 10 to the second power, that's 100. So a hecto means 100, a hectometer in HM would be 100 meters. And you can see how this works as I go up the scale. This allows me to do conversions between these two because now I have an equivalency statement that I can turn into a conversion factor if I want. I can write 100 meters over 1 hectometer, or I could say 1 hectometer for every 100 meters, and now I can convert between hectometers and meters. So you can keep going up here. I just want to point out one thing here. This is a jump of 3 powers of 10, so the kilometer is 1,000 meters, but the megameter is 1,000,000 meters, and then it goes to 1 billion and then to 1 trillion. So it goes up quickly there. If you go down, this is how you want to look at this. 10 to the negative first power, that's the same as 1 over 10. So a decimeter, a dm, is 1/10 of a meter. So I can write this two ways. I could say 1/10 of a meter equals 1 decimeter, or I like to write it like this. 1 meter equals 10 decimeters. If you multiply both sides by 10, that's what you get. Centimeters, that'd be 1/100th of a meter equals a centimeter. 1/1000th of a meter equals a millimeter. And then it jumps by a factor of 10. This is a millionth of a meter, a billionth, and a trillionth. Okay, so that's how you get your little ratios from those. Here's how you convert with these. This is on your conversions, or on your note guide. This is your first question on there. Convert 400 meters to micrometers or something like that. We're going to answer this question, which is farther, 400 meters or 400 million micrometers. So to answer that question, we want to convert between these two. Let's take our 400 meters and let's convert this into micrometers. Micrometers is this little symbol here. And it's right here, micrometers. And so that means I want to use my base unit of a meter, just like we did. I want to go all the way down to here, and we want an equivalency for this. This is 10 to the negative 6. That is 1 over 10 to the 6th meters. 1/1,000,000th of a meter equals 1 micrometer. That's my equivalency statement that will help me do my conversion here. I'm going to rewrite that because I don't like to use this fraction like this. So let's multiply both sides by 10 to the 6th. So 1 meter equals 10 to the 6 times 1. That'd be 10 to the 6th micrometers, or 1,000,000 micrometers. I'm going to use that to do my conversion up here. Times a ratio. I want meters to cancel, so I'm going to put meters on bottom. And I want to get into micrometers. Micrometers goes on top. And 1 meter on bottom equals 10 to the 6 micrometers on top. If I do the math here, this is like 400 over 1. 400 times 10 to the 6 times 10 to the 6, that'd be 6 powers of 10. So that's going to be 1, 2, 3, 4, 5, 6. That's 400 times 10 to the 6. A meter times a micrometer on top, divided by a meter. I'll write all this out for you. A meter times a micrometer. And then for units on bottom, I get a meter. A meter divided by meter, those drop out. I'm left with just micrometers. That's what I want. 1 times 1. I don't need to write that. That's divided by 1. So this is just 400 million micrometers. Well, that's perfect. That's what I want for my answer. 400 meters is 400 million micrometers. Well, that's the same as what we have here. So neither one is farther. They're the exact same length. And that's how you convert in metric. Okay, the rest of your conversions on there, you can practice here. I'll do 2 of these for you. I'll do number 2 because it has you jump across a unit barrier. And I'll do number 4 for you. I'll give you a hint for number 3. Use this. A centimeter cubed equals 1 milliliter. And that's from your little chart there. And that'll help you out. For number 2, we're going to take 345.6 milligrams, and we want to convert to kilograms. So I want to multiply by this ratio here. We want to know how the milligram relates to kilogram. I go to my chart here. The base unit is the gram. We're measuring mass. I go to the milligram. That's down here. So I want to relate this, the milligram, to the kilogram up here. And this gets a little bit harder because everything's related to the base unit. This is the base unit times 1,000. This is the base unit times 1/1,000. So there's a big difference between these two. You can just take your powers of 10 here and add them up. The total gap between these two is 6 powers of 10. So you could do that if you wanted to, if you can figure that out. That's a million times different. But I like to do it like this. We're in milligrams right now. So let's go from milligrams to the base unit gram, and then from gram to kilogram. And I can do that by using my old chart, no problem here, because this is my base unit, the gram, times 10 to the negative third power. That's 1 over 10 to the third power, 1/1000th of a gram, my base unit, times 1/1000th, equals 1 milligram. I don't like to write it like this, so let's multiply both sides by 10 to the third. I get 1 gram equals 1,000 milligrams. So let's use that for our first conversion. 1,000 milligrams. Taking this part of my equivalency statement. Why did I choose milligrams on bottom? I want the milligram to cancel, and I'm going to put the 1 gram on top. And if I do the math here, the milligrams will cancel. I'll be left with units of grams. I don't want that. I want to get to kilograms. So let's keep going. I'm going to put grams on bottom here. Let's get into kilograms. Let's go up to our chart here. Our base unit, the gram, times 10 to the third, that's 1,000. So a gram, 1,000 grams equals 1 kilogram. 1,000 grams equals 1 kilogram. Grams will cancel because I have them on top and bottom. I'm left with kilograms. My answer will be 345.6 divided by 1,000 divided by 1,000 again, which would be 0.12345 kilograms. Okay. For number 4, centimeters to cubic meters, we have to do something different. These are cubic measurements, and our base units, these are not in cubes or squares or anything else like that. So here's how we do this. For number 4, I'm going to take 127,987 cubic centimeters, and I want to convert out of cubic centimeters into cubic meters. How do we do that? Well, we need to know, how does the meter relate to the centimeter? So we'll write that down here. How many meters equals how many centimeters? I go to my chart. The base unit now is the meter. Centi's right here. And this is 10 to the negative second power. That's 1/100th of a meter equals 1 centimeter. 1/100th of a meter equals a centimeter, which means 1 meter has 100 centimeters in it. So I'm going to write it like this. Now that's a length measurement, but I want a cubed one. So how do I get the relationship between the cubes? Well, if I just take this side and cube it, and this side and cube it, if I do the same thing to both sides, they're still going to be equal to each other. And so 1 cubed is just 1, and a meter cubed is a meter cubed for units, equals 100 cubed. 100 cubed is, you can do the math if you want to. This is 10 to the second power, raised to the third power is 10 to the sixth power. And I get centimeters cubed is just centimeters cubed. So this is my ratio now. This is my conversion factor. I can plug in to my ratio up here. So 1 meter cubed is 10 to the 6 centimeters cubed. And now I can do my mass. Cubic centimeter cancels. And I'm left with this divided by a million. If you divide that by a million, you get 0.127987 meters cubed. Okay, I hope that helps. Another way to see this one, I'll write it one other way here. You can also think about it like this. And some of you might like this better. A centimeter cubed can be written like this: a centimeter times a centimeter times a centimeter. And if I do this conversion one at a time, a centimeter on the bottom, meter on top, I use this 1 meter is 100 centimeters. Do that again, 1 meter on top, 100 centimeters on bottom. Do that again, 1 meter on top, 100 centimeters on bottom. If I do that 3 times, I take this centimeter, it cancels, this one it cancels, and this one it cancels. I'm left with meters cubed on top, and I divide by 103 times, which is the same as dividing by a million. Okay. The other ones I hope you can figure out. Send me an email if you can't, and I'll help you out with them. The last one, you have a little density problem. Density equals mass over volume. In this problem, they give us, they want us to calculate volume, so we're solving for this. And they want to know the volume occupied by sample of lead. Here's our density, how many grams per cubic centimeter, and it gives us the mass. So we know the density and we know the mass. We want to make sure our units work out here. Our density was given in grams for the mass divided by cubic centimeters for the volume. The mass was given in kilograms. Well, that's not right. I need to have that in the correct units. It needs to match my units for my density, which is grams. So let's convert kilograms to grams first. 2.5 kilograms. You can look at your little chart again, see if you can set that up. Kilograms on bottom, grams on top. 1,000 grams equals 1 kilogram. These cancel, and I'm left with 2,500 grams. Now this is going to be plugged in for my mass here, and I plug in my density on this side. So I get 11.34 grams per cubic centimeter. That's my density in the density spot, equals my mass, 2,500 grams, divided by my volume. I'm just going to call my volume V. We're going to solve for that variable. Okay, so this is the most common algebra error I see all year. It doesn't matter if it's AP Chemistry, AP Physics, General Chemistry. This is the most common algebra error I see all year. If I want to get the V by itself, I need to get out of the denominator first. So I'm going to multiply both sides by V. V divided by V is 1. So this drops out on this side, and I'm left with 2,500 grams on this side. Equals V times 11.34. And now I want V by itself, so I'm going to divide by 11.34 grams per cubic centimeter. So V equals 2,500 grams divided by 11.34 grams per cubic centimeter. If you type this in your calculator, you get 220.459. Let's look at our units. A gram divided by a gram over a centimeter cubed. How do I do that? Well, if you divide by a fraction, dividing by a fraction is the same as multiplying by the reciprocal. And so if I'm dividing by grams per cubic centimeter, that's the same as a gram. Whoops, I'm not tracking here. That's the same as a gram times the reciprocal of my fraction down below. That's centimeters cubed over grams. Well, grams divided by grams, those cancel. I'm left with centimeters cubed. Don't stop here. We want to check our significant figures. What kind of math did we do? Only multiplication and division. Our rule is least number of sig figs for our starting numbers. So this has 4 significant figures. This has 2. So my answer needs to have only 2 significant figures. That's going to be this one and this one. So my answer would be 220 centimeters cubed. Okay, that's your last little bit of help on your note guide there. I hope that helps. You have one thing that doesn't have any math involved, the classification of matter. We'll talk about this more when I get back, but matter can be separated into 2 different things, mixtures and pure substances. Pure substances would be compounds and elements. Compounds would be like H2O or C6H12O6, like glucose. Elements would be things like hydrogen, oxygen, fluorine, things like that. And mixtures would be things like salt water or a cookie. These we see all the time in life because most things are mixed together. Pure substances you don't come by pure substances very often. It costs a decent amount of money to make these by themselves, pure water. And you can get a pure substance by taking a mixture and physically separating it. What does that mean? It means that you can take a mixture like this, maybe salt or sugar and water. You stir it up. If you stir it up, it looks the same all the way throughout it. That's a homogeneous mixture. It looks the same all the way throughout, uniform composition. And a mixture, this is H2O and maybe sucrose. So these 2 things stuck together in here makes a mixture. After you stir it up, we can get those out by physically separating them by evaporating the water off. If I evaporate the water off, I'll separate out the water, the H2O will come off, and I'll be left with the sugar in my glass, and I'm left with my two pure substances again. So all mixtures can be separated physically. If it can't be separated physically, it's probably bound together chemically, like the C6H12O6. All these elements are stuck together chemically, and then it's a pure substance and it's a compound. So we'll talk more about that as we learn more about chemistry, but the first chapter has that little division in there. Okay, and we'll talk more about these separations later. Finish your chapter 1 problems, and hopefully I'll see you soon.